Alkanes are good fuels because burning them converts many relatively strong carbon-hydrogen and carbon-carbon bonds into even stronger carbon-oxygen, double bonds in carbon dioxide and oxygen, hydrogen single bonds in water, and that net formation of stronger bonds releases a large amount of energy. Think of a molecule of ethane, like a short chain made of carbon, links with lots of hydrogen beads attached. Each carbon, hydrogen, and carbon-carbon bond holds energy. And when oxygen comes in during combustion, those bonds break, and new bonds form that are lower in energy and much more stable. Breaking bonds costs some energy, but making the new carbon-oxygen double bonds in carbon dioxide and oxygen-hydrogen bonds in water gives back more energy than was used, so there is leftover energy released as heat. Because ethane and other alkanes have many carbon-hydrogen and carbon-carbon bonds available to convert into those very stable products, the total energy released is large, which is why they make good fuels. You can picture it like replacing medium-strength springs with very tight springs and getting extra snap energy out of the change. A common mistake is thinking that stronger bonds always give more energy when formed. What matters is the difference between bonds broken and bonds formed, so focus on net energy change rather than individual bond strengths. Another misconception is that carbon-carbon bonds are unimportant. While carbon-hydrogen bonds often dominate the energy picture, carbon-carbon bonds contribute substantially in larger alkanes and increase the total energy released per molecule. A practical tip is to compare typical bond energy numbers qualitatively. Carbon-oxygen double bonds and oxygen-hydrogen bonds are notably stronger than carbon-hydrogen and carbon-carbon bonds, so their formation drives the large heat release. Visit www.gumballdegree.com to find more videos and resources on how bond energies determine fuel behavior.